Hey, welcome back to Engineer's Workshop. Still working on the balancer, harmonic balancer spacer here. Got the ends done. My son welded it up and I did an initial fitting on this. I sized it to be like a line-to-line fit for the projection of the pulley that's coming out of the crankshaft, and it's tight going on. So I need to shave just a thousandths or so off of here. I don't want to end up with any significant amount of clearance, obviously. But let's go over to the lathe, and I've got it chucked up, and best I can do with the 3-jaw chuck without a lot of funky shimming is about, a 2/1000ths total run out. So I blued it, and I'm going to take the lightest of cuts on that bore and then test it again over at the Spitfire. Then once we get that fitting and seating, I will show you what I've got going on with these 4 mounting holes here. So let's get cracking here. And I go about just a 0.5 or so more. Just enough to take the Sharpie off of there. And now what I think I'll do is I'm going to mark the jaw so that I know exactly how to replace this, and we'll do a test fit. All right, well, don't know if you can see that, but it's on, and there's really no play. So that's the fit I'm looking for. You can see that it's really not big enough to pilot that belt at all, which is a bit of a shame. He may have to end up putting a, I don't know, like a little tiny counterbore on the end of this, and then we'll make a flanged piece that sandwiches in between there to act as a belt lead in if this belt has any tendency to walk out. I'm not sure under here if there's any other idlers that will pilot it. Actually, we can look. Okay, there's one idler that has flanges that will keep that belt basically running true. And like I said, they use the harmonic balancer as another flange surface on there. So, okay, let's get over and set up for the mounting holes. Okay, I started to measure the harmonic balancer, and really the only way I had to do it was to use some good digital calipers. And I started by measuring the inside distances between all of the mounting holes and that center hole. And then I went and measured inside to inside for all of the outer mounting holes. And I noticed that some of those dimensions were pretty close, and obviously some deviated, but I laid that out in SolidWorks. And one of the things I started noticing when I looked at the pattern, if you take and you lay a circle on here, is all of those holes appear to land on the same circle. So that led me down a path that these things were put in at a specific radial offset, and the things that they changed were the angles. So in measuring the angles, I got something close to 90, something close to 90, something close to 82, and then something close to 49 degrees off of that oddball for the locating hole. So based on that assumption, I laid out a sketch with what I assumed was the actual design parameters for the location of those holes. Ended up with a base circle of 1.811. That is, I believe, 46 millimeters. We got 3 holes, you know, at 90 degrees apart. And then, well, there's 90 here, and then this one is 8 degrees off. Rotationally, it's 8 degrees off from a true 90. And then this hole is actually 4 degrees off of what I would call horizontal. You know, it's skewed 4 degrees. And if you take this set of holes, let's see if I can do this on SolidWorks. Bear with me with my zoom. If I take this point and this point, if I take this point and the origin here, and I say they are coincident, you can see that my assumed pattern lands pretty much dead on the money on top of what I measured from all of the, you know, individual measurements. So that being said, it's very easy at this point to lay out that pattern on both faces of the spacer. I just had to create a mirror image of that pattern, which I did about a mirror line to give me the opposite view of this for the other side. There's the opposite hand view of it. So I have my 2 sketches, which is the original and a mirror image of it. I have to figure out which one of these is the correct one to use for the face of the spacer that mounts to the engine. So basically it has to look like this from where we machine it. So if I orient this, that is the locating hole. We have 3 holes that are on a 90. I should designate that. So we got 3 holes that are visually at 90 degrees to one another. And then we've got one that is offset. That's our offset hole. And this is our alignment hole. So it looks like this. We have 1, 2, 3. We have the offset, and then we have the alignment hole. So I have to use the original sketch on the first setup on the K&T. So I have a V-block in the Kurt vise, and I've got a couple of hose clamps holding the spacer to the V-block, and that is basically just so that I can, in the second operation, take a second V-block, clamp it, turn it over, and then machine the other end. That way I won't lose orientation. I'll keep everything referencing against this jaw of the chuck. So my 3 holes that are going to be at 90, I'm going to reference here. And then our oddball is going to be going to look like this. Then our oddball is going to be here, and our alignment pin is going to be there. So first order business is indicate on that bore. Okay, I'm indicated within a 0.5 thousandths. Now I have to establish the offset. The offset is 0.9055. For each crank here, I've got 100 thousandths. And I come up to the vernier, so that's 0.9, 0.905 and a half. And we'll lock the slide so that that doesn't move. Okay, now we want to set up for this first hole. So I'm going to rotate the head until we're at, this will be 90 degrees, which is right there. This scale and this worm drive is extremely accurate. It's basically just like a rotary table built into this head. In fact, you can replace this hand wheel with index plates from a K&T rotary table and do extremely accurate divisions on this head. If you have a bolt pattern with 23 holes, this can do it. So let's drop our, well, we're not going to drop our quill down. What we'll do is we'll spot each location and then we'll come back and we'll drill them. I think we'll put the belt on so we've got some resistance here. See what kind of RPM we've got dialed in. That's reasonable. I'm just going to double check this visually and make sure we're doing this correctly. Now this last hole is at 82 degrees instead of 90, so we're going to have to go to 98 degrees. My math says this last one's at 221. And this last hole is a 1/4 inch. See if we can determine what kind of feed we have here. Seems reasonable. Don't think I'm through. I think my quill stop is stopping me. No, I'm through. Closest thing I have to the other size, which is metric, is an 11/32. First hole, the oddball, is 172 degrees. And then the rest of these are at even 90-degree increments. One thing I believe my son may not have thought about is how close these clearance holes are to the ID of the tube. I think he's just made it. I mean, it feels like the drill might be skimming the tube as it breaks through. Get a good close-up of this quill trip mechanism working. Okay, with everything flipped over, I've got the mirror image pattern marked on here. You have to refigure those angles. All I have to do is zero on this boss. My Y dimension should be okay. My X dimension is what changed. And then once I'm zeroed, I can finish this pattern. Now, 82 degrees from here, 10, 20, 30, 40, 50, 60, 70, 82. And before I spot it, I'm going to do my math. So we're looking like this. We are left of a true 90. And there's the 180. Okay, we're good. And we'll write down the 188. Actually, well, I'll put a little spot here in case he wants to put a pin, but I don't think he needs one. First hole is at 90. Last hole at 188. Well, I've already peeked through it, and we are aligned, all four of those. And when I find the right orientation for this, there it is. Gotta admit, that one had me sweating. So a lot of operations, a lot of opportunities to screw up. So all now that Brennan has to find is some metric cap screws or hex bolts long enough to, and obviously 8.8s or whatever, 12.9s, whatever they grade those, so that he can torque that in. And that should work out. So I'm going to take it over to him now and show it to him. Hope you enjoyed that. I enjoyed that project. I hope to move on to something a little less nerve-wracking, a little simpler. Maybe I'll take care of a couple of little things on the lathe or on the K&T. Actually, maybe, you know what? I might go back onto the radial arm saw casting. It's about time I clean that up and get that radial arm saw back together, so that's a little less nerve-wracking. So thanks again for watching, for subscribing. Take care of yourselves, stay away from wildfires if you can, and until next time, as always, from Engineers Workshop, stay safe.